What if I told you that the most powerful force in the universe is completely invisible? Right now, as you watch this video, an ancient force is holding you to your chair, keeping the Earth in its orbit, and sculpting the grand architecture of the cosmos itself. For millennia, we've gazed up at the night sky, marveling at the stars and planets. But few truly grasp the unseen hand that's orchestrating this cosmic symphony. Today, we're going to reveal the universe not just as a collection of beautiful objects floating in space, but as a dynamic masterpiece carved by gravity, the universe's silent architect. Welcome to a journey into the hidden forces shaping everything we know and everything we don't. Our story begins with a simple observation. In 1687, Isaac Newton watched an apple fall and gave us our first glimpse of gravity's true nature. But Newton's gravity was just the opening act. It took Einstein's revolutionary insight in 1915 to reveal that gravity isn't just a force pulling objects together. It's the very fabric of space-time itself, warping and bending under the influence of mass and energy. Think of space-time like a stretched rubber sheet. Place a bowling ball in the center, and it creates a depression. Roll a marble nearby, and it spirals around the depression. Not because the bowling ball is pulling it, but because the marble is following the curved path through warped space. This is gravity in action. The fascinating thing about gravity is that while we can't see the force itself, its fingerprints are everywhere. From the ocean tides on Earth to the spiral arms of distant galaxies, gravity leaves its signature on everything it touches. Let's witness gravity as the universe's master sculptor. Billions of years ago, the cosmos was filled with nearly uniform clouds of hydrogen and helium. But gravity doesn't like uniformity. It seeks out the tiniest irregularities and amplifies them. Slowly, inexorably, gravity pulled these gas clouds together. As they collapsed, they heated up, and when temperatures reached 10 million degrees, nuclear fusion ignited, and the first stars were born. But gravity wasn't finished. It gathered these stars into clusters, then into the magnificent spiral and elliptical galaxies we see today. Inside each forming star, gravity creates a delicate balance. It crushes matter inward with tremendous force, while nuclear fusion pushes outward with equally tremendous energy. This cosmic tug-of-war sustains our sun and every star in the universe, gravity literally keeping the lights on across the cosmos. And it doesn't stop there. Gravity choreographs the precise ballet of planets around stars, creating the stable solar systems that allow worlds like Earth to exist for billions of years. Without gravity's guiding hand, there would be no planets, no stars, no galaxies, just cold, empty space. But gravity has a dark side, literally. When the most massive stars die, gravity wins the ultimate battle. The star's core collapses in less than a second, crushing matter so intensely that it creates a black hole, a region where gravity is so strong that nothing, not even light, can escape. These cosmic monsters are gravity's ultimate expression. They can tear apart entire stars, consume gas clouds the size of solar systems, and when two black holes collide, they create ripples in space-time itself that we can detect here on Earth. Gravitational waves that confirm Einstein's predictions over a century later. Massive objects don't just bend space-time, they bend light itself. This phenomenon, called gravitational lensing, turns massive galaxies into cosmic telescopes, magnifying and distorting the light from even more distant galaxies behind them. It's like the universe has built-in reading glasses, allowing us to see farther and deeper than ever before. Then there are neutron stars, the collapsed cores of massive stars so dense that a single teaspoon would weigh as much as Mount Everest. These cosmic lighthouses spin hundreds of times per second, beaming radiation across space like celestial strobes, all held together by gravity's unrelenting grip. Here's where things get truly mind-bending. Gravity doesn't just shape space, it shapes time itself. Near massive objects, time literally runs slower. This isn't science fiction, it's measurable reality. Clocks at the bottom of skyscrapers tick slightly slower than clocks at the top. GPS satellites must account for this time dilation, or your navigation would be off by miles. In 2015, we achieved something Einstein thought impossible. We directly detected gravitational waves. These ripples in space-time, created by colliding black holes over 1 billion light-years away, stretched and compressed space by less than 1/10,000th the width of a proton. Yet we detected them, opening an entirely new window into the universe. Understanding gravity's relationship with space-time might one day lead to technologies we can barely imagine. Warp drives that compress space in front of a spacecraft while expanding it behind. Wormholes that connect distant regions of the universe. While these remain theoretical, our growing mastery of gravity continues to reveal new possibilities. The ultimate frontier lies in uniting gravity with quantum mechanics, understanding how gravity works at the smallest scales, potentially revealing the true nature of space, time, and reality itself. Zoom out to the largest scales imaginable, and gravity reveals its grandest masterpiece, the cosmic web. Like a three-dimensional spider's web stretching across billions of light-years, gravity has woven the universe into filaments of galaxies separated by vast cosmic voids. This is architecture on a scale that dwarfs human imagination. But here's the kicker. Most of the gravitational influence shaping this cosmic web comes from something we can't see: dark matter. Making up 85% of all matter in the universe, dark matter reveals itself only through its gravitational effects. It's the invisible scaffolding upon which everything we can see is built. And then there's dark energy, an even more mysterious force that's accelerating the expansion of space itself, working against gravity on cosmic scales. Together, dark matter and dark energy make up 95% of the universe. We live in a cosmos dominated by forces we barely understand. This cosmic tug-of-war between gravity and dark energy will ultimately determine the fate of everything. Will gravity eventually win, pulling the universe back together in a big crunch? Will dark energy tear space apart in a big rip? Or will the universe expand forever into cold, empty darkness? Gravity holds the key to these ultimate questions. From the quantum realm to the cosmic web, from the birth of stars to the death of the universe, gravity is the invisible thread weaving together the story of existence itself. It's the force that made planets possible, that lights the stars, that holds galaxies together, and that will ultimately decide the fate of everything. The next time you look up at the night sky, remember, you're not just seeing distant lights. You're witnessing gravity's greatest masterpiece, a universe sculpted by forces so fundamental they define the very nature of space and time. What aspect of gravity's cosmic influence fascinates you most? Let me know in the comments below. And if you enjoyed this journey into the hidden forces shaping our universe, make sure to subscribe and hit that notification bell. We've got more cosmic mysteries to explore together. Until next time, keep looking up. And remember, in a universe shaped by invisible forces, the most profound truths are often hidden in plain sight.